So now what we can do is, we can talk about competitive equilibrium. Okay, so what I'm going to do is I'll define competitive equilibrium for two goods environment. Okay, pure exchange economy environment, but you can define, in a similar way, okay, for any number of commodities, any number of consumers. Okay, so let me give you the definition first. Okay, so how do you define competitive equilibrium in this particular environment? So the definition is actually, I mean, the definition of competitive equilibrium across all these environments, that doesn't change. There'll be just slight modification. Okay, but it's mostly about, individuals maximizing their utilities, and then figuring out their demands, and then demand must equal the supply, which is in this case is going to be total endowment. Okay, so these are basically going to be the components. Okay, but with the scenario that we have here, there is one thing that we should be a little careful about, that individual's utility is not just affected by his own consumption, but is also affected by the other player's consumption. So here, it's kind of a setting that we have seen, when we talked about games, strategic games. Okay, where individual one makes his choice, individual two makes his choice, and their choices together determine their payoffs, right? So it is like a game, so let me define competitive equilibrium in this particular setting. Okay, so given this two consumer two good setting, we say that px star py star, okay, this is the prices, okay, price pair of prices, px star py star, and an allocation x1 star y1 star x2 star y2 star, okay, is a competitive equilibrium okay. So this pair is a competitive equilibrium, okay, the price and the allocation. So this is competitive equilibrium prices, okay, and this is competitive equilibrium allocation. Okay, so this pair is known as competitive equilibrium if first, okay, so we have price takers, consumers are price takers. So given px star py star, consumer one maximizes its utility at x1 star y1 star, holding x2 star y2 star as fixed. Okay, so basically, you can say that x1 star y1 star is the best response demand of consumer one to consumer two's choice x2 star y2 star. Okay, so x1 star y1 star solves maximize with respect to x1 y1 u1 x1 y1 x2 star y2 star. Okay, so he's going to take x2 star y2 star as given because he cannot choose it, right? I mean, x2 star y2 star is not in individual one's control. Okay, it is something that individual chooses. So he's going to take this as given, and he's going to figure out his best response. Okay, and that is something that he's going to get by maximizing his utility subject to the budget constraint. Okay, which is px star x1 plus py star y1. Okay, and this should be less than or equal to px star omega 1x plus py star omega 1y. Okay, and of course you also have non-negativity constraints, okay, which I'm not writing. Okay, so x1 star y1 star must solve this problem. Okay, which means that x1 star y1 star is the best response demand when x2 star y2 star is the decision of consumer 2. Okay, and similarly, you can write the same thing for consumer 2. Okay, so x2 star y2 star solves the utility maximization problem of consumer 2 holding other players' decision as given. Okay. Subject to the budget constraint, which is Px star x2 plus Py star y2 is less than or equal to Px star omega 2x plus Py star omega 2y. Is that fine? So x1 star y1 star is the best response demand of consumer 1 given consumer 2's demand, x2 star y2 star, and x2 star y2 star is the best response demand of consumer 2 given consumer 1's demand. So basically x1 star y1 star, x2 star y2 star is a Nash equilibrium given these prices. Okay, this is what this whole thing is all about. Okay, is that okay? Fine. So that's the first condition. Can you tell me what should be the second condition? Whenever we are talking about competitive equilibrium, what should be the second condition? Very good. Okay, market clearing, absolutely. Total demand must equal total endowment. That's right, absolutely, very good. Okay, so the second condition is that whatever you're demanding must be equal to the total supply. Okay, so x1 star plus x2 star must be equal to omega 1x plus omega 2x. Okay, and then y1 star plus y2 star must be equal to omega 1y plus omega 2y. Is that clear? Any questions? Okay, so this is how you define competitive equilibrium. Okay, two components. One is individuals are making a utility maximizing choice. Okay, and in this case, because it's kind of a game, so we are going to use Nash equilibrium, okay, to determine the choices. So x1 star y1 star x2 star y2 star is a Nash equilibrium of this game given these prices, and the demand must equal supply. So that completes the definition of competitive equilibrium.